the Office of Infrastructure. He focused on safety and security for bridges and tunnels. Prior to joining FHWA, he conducted research in structural engineering regarding blast effects, dynamics, and experimental structural response performance for FHWA, DHS, and many other agencies for almost 38 years. He holds a professional engineering license from the state of Mississippi and has a license issued by the Structural Engineering Certification Board. Thanks, Vince.
Okay, thank you, Jennifer. Hopefully you can hear me. I know that's a common thing. Just give me a confirmation, please.
Yep, we can hear you loud and clear.
Very good. All right, so thank you. So I'm going to talk about bridge security engineering design and also give you reasons why talk about it. There is no legislative mandate for owners to implement bridge security design, but there are ways states can use money they get from highway programs to implement bridge security design. And I'll talk a little bit about that. Also, we've had many partners in my career with the Corps of Engineers. We started down this road. Department of Homeland Security was a big player, supported a lot of the funding, and also coordinated with Transportation Security Laboratory, TSL, and also the Transportation Security Administration. Corps of Engineers was also is now still a partner. We have an interagency agreement from my office for Federal Highway with the Corps of Engineers at ERDIC and also at the Protective Design Center, which is out of Omaha. We've also coordinated with NIST, many people in academia and also in the private sector as well. Partners I talk about are not necessarily people who give us money, but anybody that helps us solve this problem or contribute to solutions on this. So again, I'll talk about this purpose for this. And really, this is sort of a primer on bridge security engineering design. We are developing a course. It's 4 hours to talk about this, which is still a brief course. But the idea is to educate and motivate owners and stakeholders how they can conduct risk assessments, and also how can you identify security vulnerabilities. And really, we focus on intentional threats, but what you do to protect against intentional threats can also help you against accidental threats. And we'll talk about that. And we have some examples of how to create countermeasures if one accept the consequence of a risk of a vulnerability, then you implement a countermeasure or you protect. And I'll cite resources that are available online and mention some others. So why bridge security engineering? Well, of course, we know of the main event that occurred on 9/11. There was a blue ribbon panel that was convened in 2003 to identify what does the nation need to do to protect the transportation infrastructure against terrorist threats. And there is a report online that I will show that documents what that blue ribbon panel recommended. And we'll talk about the bridge security engineering philosophy. It really comes from physical security. And so we've adapted that philosophy for bridge security engineering. I will show a brief synopsis of how we assess risk, vulnerabilities, and security. There is something called anti-terrorism vulnerability assessment, or this ATVA, the decisions that owners have to make, and based on those decisions, whether you decide to implement or not. A valid choice is to do nothing, but you still should document why you're willing to accept certain consequences, either from a cost assessment or whether you're just willing to accept certain risks. And then if you do decide to implement security, what kind of mitigation measures and resources are available to help you make those decisions about how to mitigate. And then I'll summarize with knowledge gaps that we have and needs. And the type of research that we're actually trying to fund. Motivation, the impetus. We know that there are worldwide terrorist attacks. Now, that doesn't mean that in every case there was an actual attack that took place. So this data is from the Mineta Institute. University of Maryland actually did a sorting through data, and they got some of this data from the Mineta Institute, which is online. And since 1979, an increase in attacks, and we know that in 9/11 there was an increase. But again, in our country, I don't know of any attacks that actually have occurred on a bridge per se, but there are many thwarted attempts. So that's something to keep in mind. But we know worldwide in theaters of war, there have been actual attacks on bridges. So what are the terrorist goals? Well, we know that one, they want to make a statement. And so one of their bloodlines to making that statement is getting that event in the media. They want to have publicity for their cause. They would like to destroy a landmark or some critical asset that would disrupt our economy or even our way of life. Another goal is to exert political pressure, advance some imperatives, seek revenge, and the list goes on, as you can see. Maximize casualties, disrupt the economy. So these are goals that we know about, and they're probably self-evident. Their tactics, not necessarily likely to use conventional civilian bridge demolition or military tactics. However, they could. The possible course of action, they would like to have a high probability of success, and whatever event or target that makes an impact to maximize damage and casualties. And can they actually obtain materials to attack a certain type of target? How quickly can they attack a target? Can this be a covert type operation? And is it simple and easy to coordinate? And the flexibility of the target. Can they attack more than one target? Make an attack on one target as a diversion, and then have a setup on another target where people are moving to. So these are sort of their tactics about this. So we know transportation infrastructure are potential targets, and that could include bridges and tunnels. The importance of our transportation infrastructure, we know it supports our economy. It allows us to freely move. And also, it is a national defense asset in the sense that if the military needs to move troops during some sort of national crisis, then they will use our transportation infrastructure for that purpose. And I mentioned this blue ribbon panel report you see on the right-hand side. There is a link to that. It's a publicly available report, was published in 2003, and it is easy to read. It's not a very big report, but I actually end up reading it over and over quite a bit. There are some good recommendations in there, and we actually have developed a research plan following this to execute those recommendations. And this is that report. It was published in 2006. The multi-year plan for assessing bridge and tunnel security, and we're still executing this plan. It's a function of dollars, and our office does not have all the money to execute this research. So we rely a lot on our partners and collaborators. There are things called state-pulled fund studies, and so this is one way we can collaborate with other partners. Is we need other people to help contribute to solve these problems, either through academic research in the private sector on case-by-case projects. And anyhow, this report is available online. You're welcome to read it. If you have comments about it, I will accept emails, and I'll give you my contact at the end of this. But again, we have not updated this report since 2006 because we still are executing the plan, and the plan is still valid. Our security design philosophy. So we talk about the 4 Ds of physical security: detect an event, deny the access to the target, delay the action of a terrorist, and the last, which sometimes is the most costly, but not necessarily always, but that's defend. And that really relates to hardening the structure, either somehow making the structure more robust, adding redundancy in the design, so that if there are critical structural components that are attacked, we don't lose the bridge. And that's our main goal in our physical security, is defending what we think are the most critical structural components that are accessible to potential threats. Again, defending, if you have to harden a structure after it's built, that can be more costly, but we have ways to do that. The cheaper thing to do is implementing physical security in the beginning of the design, and there are things you can do to add a little extra robustness to the structure that won't add extra costs. And we think when you implement physical security and improve its robustness, you also improve its resilience, and perhaps the life cycle costs are reduced as well. So there are some of our reasons. Another comment, or D, that was coined by one of my colleagues, Steve Ernst, who retired from the office, is deceive. Can you make it look like there are some of these physical security measures in place? It may not be real effective, but it might be possible to make it look like there's something there, and that may basically thwart an attack in itself. So again, when we start out in this security design philosophy mode, the first thing we want to do is, what are the hazards or threats? And then we use our vulnerability assessment, the anti-terrorism vulnerability assessment, as a starting point to look at hazards and how they relate to structural components. So we identify critical structural components, and then we identify consequences of the hazard to these critical components. And so we use this anti-terrorism vulnerability assessment, guides that, and it helps us identify, again, the structural components that might benefit from additional protection. And in this process, when you do the vulnerability assessment, the owner will look at, can I accept the risk of losing certain components, or do I need to add some kind of protection measure, or do I need to implement some other aspect of the 4 Ds in the physical security? One of the things that we also have done is, when we have come up with protection measures, physical testing, either at reduced scale or component level, can evaluate the performance of these protection measures. And we have done that and have been successful in evaluating what will work. And also there are numerical modeling that goes hand in hand with that. And so it's a hybrid approach, and we've been successful in implementing that, and it can be cost effective on certain projects. And we have done this for some specific projects where we have physically tested certain parts of the components, and then we've also gone hand in hand with some numerical modeling. So let's talk about risk. I think most of us probably are familiar with this concept. Risk is the possibility of loss of some asset or injury. Traditionally, it's defined by this equation. You have a failure of probability, or some might call a fragility type assessment, times consequences, and you end up with a utility value. And so basically, when you're doing a risk assessment, you evaluate different scenarios of risk, and you compare these utility values to give you what might be the highest consequence scenario. So why do we care about risk? Well, we know we accept risk every day in our personal life and our job. And this is a rhetorical question. We give a course and we ask this of our students or the attendees: is anyone to actually assess risk in their position? And there are a number of ways to assess risk. And we'll talk about how we actually do this. So we look at a hazard, some event that's going to cause harm or damage. We look at, can it occur, the consequence of the results, and the cost, or the consequence would result in either cost, loss of dollars, loss of use, some delay of use. So these are some tangible values. And we have actually done some estimates. If we lost $1 billion bridge, for example, in some high density metropolitan area, experts have told me that that cost could be orders of magnitude times the cost of the asset. So in other words, could be a loss of 10 billion to 100 billion possibly, because of the impact on the economy in that region. It's not just the replacement cost of the bridge. There are a lot of other costs, as you could imagine, that would relate to the loss of a bridge. So the threats that we look at, let's first talk about what's the main reason for failures of bridges. And it's actually hydraulic reasons. And hydraulic covers scour, flooding, anything that has to do with water. It turns out 80% of the bridges in the nation are over water. And so there are a lot of hydraulic reasons for bridge failures. Collision is number 2, vehicle overload, fire, deterioration. These are in order of the most reasons. The intentional threats, which there are some that are unintentional, collision is a potential intentional threat. It's not as likely as perhaps maybe fire, explosive devices, intentional cutting, which we would call non-explosive cutting devices, and others. We do know that there is the potential for UAS type systems to deliver threats, and that is something we're concerned about. So when we're looking at our threats in this vulnerability assessment, we've talked about these. We consider under the explosive threats, there are vehicle borne, say like in the trunk of a car, a van, hand in place, which would be smaller devices, could actually be like a backpack or portable. Fire, potentially. More often than not, fire is an accidental threat. It actually occurs quite a bit on bridges, but again, it could become an intentional threat. Non-explosive cutting devices and impacts from vehicles or vessels. Again, we don't think there's a lot of risk from this, but it is a potential threat we need to evaluate. And so the risk equation, again, the traditional risk, some hazard times a consequence. So you have a likelihood of the event. And then you also have this fragility curve, which would relate to the magnitude of the event and the probability of damage. We don't always have a fragility curve for terrorist type threats because they are so uncommon. We don't have a lot of data to actually develop statistical likelihood. So we have to make some informed guesses about that. We've developed a risk rating index, and actually it comes from the Blue Ribbon Panel Report. And actually James Ray, who works at ERDIC, published a 2007 paper in an ASCE journal that also goes into great detail how you do this. And so basically, instead of the traditional risk equation, we've expanded it a little bit. So you have this risk rating index, which is a function of occurrence of the threat. Then when you're looking at a specific component, you look at the vulnerability of a component, and then you also look at the importance of that component. So we do this rating within an asset. So we don't do this to compare the risk between bridges, but when we're looking at a specific bridge, We'll look at all the structural components that might be critical, and we'll evaluate through this risk rating. So it's, again, the traditional assessment usually predictable probability, but in our case, it's not predictable, as I've mentioned. It's impossible or very unlikely to assign an accurate probability. Again, we make informed guesses about this. The probability is really low. It's a low likelihood event with high consequence. So that's why we are concerned, because of the high consequence potential impact of these threats. We look at the importance, the factor I and the vulnerability. We look at these parameters, the impact of the bridge loss on social and economy, the role played by the bridge. Again, it's part of a national defense, how it supports community, average daily traffic, average daily truck traffic. And also there are other methods to rank bridges, like we do in the seismic analysis, and also symbolic importance. Now, one thing I do want to say is not to confuse iconic importance with real importance. So the importance we talk about is how important is the bridge in the node of the transportation network. And so that's really the bottom line is, when you're looking at the importance, not necessarily how iconic, but what are the impacts, as we've talked about here, on society and the economy. So this is a very big overview of how we do this. So for a given component, say if it's a suspension bridge, we might look at a suspender rope, wire rope, and we would identify for that wire rope, for example, for maybe a hand in place device, what's the possibility of the occurrence? We can identify factors. What's the vulnerability of that rope to a given threat, and the importance of that rope? Can you lose that one rope, or if you're looking at more than one, how many can you lose? And so we would typically assign a value of 0 to 1, and then you would simply multiply those numbers together. And this lends itself to a spreadsheet type analysis. And so, again, you look at this risk rating, it's the consequences times this probability related to the V, O, and I, V vulnerability, O occurrence, I as importance. Another thing to consider, what's the uncertainty of the consequence? That is, and that really relates to the uncertainty of the vulnerability. And I might say that if the uncertainty of your consequence is unacceptable, one way to address that is to reduce your vulnerability. And you can reduce that vulnerability of a given structural component through one of those 4 Ds, or a combination. Usually you can't change the occurrence unless you somehow deny access to the structural component, and usually the importance you can't change unless you change the design of your structure. So typically it's the vulnerability that we have some flexibility about changing if we have a high consequence we can't accept. So, for example, if you have a $1 billion asset is at risk, are you willing to accept a higher vulnerability? And that's a question I would pose to owners. And the Europeans tend to adopt a strategy of responding to events as opposed to hardening, because they don't think that they can actually afford that cost. But that's another subject. So, looking at some of the threats, specifically the blast threat. So our main concern is the proximity of a vehicle type borne threat that might carry charge into how close it is to a structure. We look at things as standoff, the height of burst, the charge weight, and we have some parameters we can compute from this that allow us to assess some vulnerability of certain types of structures. So that would be a first start. And the thing we do know is that standoff really helps a lot against explosive threats. And if you look at this, the scale range value Z, which is not non-dimensional, 0.2 is real close, value 1 is further away. You can see that orders of magnitude of the reflected peak pressure from a blast reduces as you allow for standoff. The problem with bridges, it's really hard to enforce standoff like you can for buildings. And I have yet found a bridge owner who is willing to close off a lane to protect parts of their bridge. That's just not going to happen. They want to use all the lanes of the bridge to allow traffic to freely move. And even on some new designs, sometimes trying to include extra standoff affects other parts of the design that might make it more seismically vulnerable. And so there are these other trade-offs that we're back to. Enforcing standoff doesn't seem to work in the design as much as trying to use other physical security measures. So again, if this is an example, if we look at an icon or schematic of a suspension bridge, when we go through this vulnerability assessment, we would look at perhaps the main suspension cable, the suspender cables, and the towers. They might be through. You could also look at anchorages. But again, we would then look at these intentional threats, collision and fire, the explosive threats, and intentional cutting against each one of these types of components. And then what we would do is, again, for each one of these components, we would assign occurrence factors for each threat, an importance factor for each component, and vulnerability factors that relate to the threat. And so we end up with a rating index. And when you go through this, there's a lot more detail than just this. But if you look at that blue ribbon panel report in the appendix, it gives a really good description, good detailed description of how you would implement this risk rating process. And so then you would then, after, for each component, you would then compute a risk rating value. And again, you could use 0 to 1, you could use 0 to 10, but you would be consistent for each one. And so, for example, if you had for a certain component, the occurrence factor was 0.3, the importance is 1.0, means it's very important, the vulnerability is 0.5, you would end up with a risk rating value of 0.01. Now, by itself, that value doesn't mean anything, but it means something when you compare it to, in some matrix form, these other components and these other threats, and you would then could end up with a heat map that would show you where are your highest consequence scenarios and what are the highest risk scenarios that you may need to do something about to reduce. So anyhow, once you get through that, there are decisions to make, and there is a tool that can help with that. This is a limited distribution tool, but if you have a need to know, you can be vetted to get access to this anti-terrorism planner for bridge. And this is a fast running engineering tool that allows you to set up certain scenarios of certain bridge components against certain hazards and evaluate the vulnerability. That is, assess what kind of damage might occur against a certain type of threat, against a certain type of scenario. Now, we don't have in this tool, if you have a consequence you can't accept, what is a design measure? We hope to implement that, but we do have some solutions. Again, you go through this and you would decide whether or not you need to mitigate against a certain threat using this analysis. And again, this is actually distributed from ERDIC, and it was developed over the last 10 years, actually. And it is a good tool, and it was validated by high fidelity numerical modeling and also test data. Some of the components that we have in there: circular, rectangular reinforced concrete columns, steel tower panels, and that might relate more to a suspension bridge. Steel cables could be for cable stays, or also suspender ropes, and reinforced concrete tower panels. That might relate to the part of a reinforced concrete tower for a cable stay bridge, for example. So your decisions, when you go through this assessment and you evaluate your vulnerability and you evaluate potential damage, you have to say, am I just going to accept that this is going to happen? And it's the do nothing choice. It's a valid choice, but it's good to document. Or am I going to prepare for the potential of this occurring? Again, you're going to let it happen, but then you're going to have some response plan in place. And this is, I think, typically what the Europeans or the Brits do. Or are you going to mitigate against this hazard? Again, one of the 4 Ds. And if your consequence is not acceptable, then my suggestion is mitigate, because that's the only way to reduce your risk of a consequence. And you would use one of the 4 Ds as your cases. Some of the measures that you can use if you decide you need to mitigate. Again, closed circuit TV, cameras, have patrols, denying, fencing, barriers, deterring. Again, it really relates to the other 2, some kind of security presence. And deterrence can be having a view or a visible measure that someone can see that it is hardened or defended. And so that relates to the last one. Again, the hardening or the defense can be a retrofit or new construction. Also, there are other sources that evaluate how to protect critical transportation infrastructure against impacts, vehicle collisions. And this report also is online and it is publicly available. Some of the other ways to mitigate, we know that you have to decide if in this test, you see there's a hole in a concrete panel, and you have to decide, can I accept that hole in my bridge tower, for example? And if I can't, what can I do? Well, there's in the lower left-hand corner, you see a schematic of how you might do a steel retrofit, and that actually be placing steel plates on outside and inside and bolting through. And we have validated that works. And that is also a very good way for new construction. You could use those plates as a formwork and leave them in place, for example. There are some resources, other resources. AASHTO had a document, 2011 Bridge Security Guidelines, and it's non-binding guidance, but it is recommended how, if you decide you cannot accept a consequence, how can you design to protect bridge columns? There are other examples where bridge security was implemented, and I'll say that I'm part of a committee. We are updating this document to include guidance, again, non-binding guidelines on how to protect other bridge components other than just bridge columns. And hopefully in the next 2 years, that document will be out. Again, you can go to AASHTO and buy this. It's not freely available. And even myself, I had to get it through our Federal Highway Library to get it. Other resources, there is a structural design for physical security, sometimes called the Blue Book. It was published in 1999. There is a new manual. It's Manual Practice 142, published by ASCE. I think it's imminently going to be out. I thought this year. I got a notice last December from ASCE that it was out, and I think they're just dealing with a few permissions of some images, but this document, the Blue Book, was updated, and there is a chapter on bridge security. And also there is a free ASCE PDF that relates to fire engineering. Again, it's more for buildings, but there is information in there that could apply to tunnels and bridges. Tunnels have a lot more information, more so than bridges. That's what we're finding out. There is also another document, NFPA 502, that you can look at that has a section on tunnels regarding fire engineering and bridges. Much more limited information on bridges. What are some of our challenges? Well, we think the threat is changing. Again, we're still dealing with how can we do a better job of identifying the likelihood of some of these hazards. And then with some structures, larger structures, there are other variables that affect the threat and vulnerability of structures. And to what level do we need to determine the vulnerability? You know, our AT Planner tool gives us an idea, but do we need to have a better idea of to what degree, how can we quantify when vulnerability is unacceptable or acceptable? And again, it's the threats are more than just blasts. We usually think of blasts when we talk about bridge security, but as I've identified, there are other hazards to consider. And what you do to mitigate against some of those hazards can also help you against those same hazards, which we would call unintentional type hazards. We're looking at still developing new solutions, experimental efforts, combining that with guided numerical modeling. And we're always looking at performance of new materials. It's still hard to beat steel and concrete when you're protecting something, but there are advanced improved steels. And with ultra high performance concrete, there are new concretes that are coming out. Again, we're challenges regarding retrofits of existing asset versus new design. That's a hard challenge, but it is something that apparently does tend to thwart some owners from implementing physical security because they look at the cost of a retrofit and sometimes it's hard for them to justify that cost. And again, if we do somehow mitigate, are we modifying the structure in such a way it might change performance against other natural hazards, say earthquakes? These are some of our needs, more R&D. I came from a research environment, so I never think we have enough research. We are looking at developing, again, what I would call rational guidelines in the sense of consistent guidelines, so everyone is using the same guidelines throughout the community. And we do have a challenge that we need to understand how to balance multi-hazards, again, earthquake example, with implementing physical security. And are there life cycle cost impacts? And again, to communicate among all disciplines. And what I mean by that is not just talking with engineers, but how do we communicate the need for physical security to the owners, to their business partners, to economists, to the social scientists, and how this might impact the community. And so we as engineers do need to do a better job of communicating what we do and how it's important and how it can help communities. And we do need feedback still from stakeholders whenever we're looking at physical security. And again, one of the things we have found out is assessing risk from fire, whether it's intentional or unintentional. Bridge fires are occurring quite a bit, and there is a database available from the Federal Motor Carrier Safety Association that shows that it's possible that at least once a week there's a bridge fire somewhere in the country. I found that surprising. One time I thought fire was number 3 on the list, but it's actually number 5 on reasons for damage to bridges or loss of a bridge. But typically when we assess fire, we think of it as intentional in our vulnerability assessment, but it's still the same threat, whether it's intentional or accident. We believe bridge security improves resiliency and safety. I think a more secure bridge is more resilient and safe. And we have a motto in Federal Highway: safe bridges are open and safe bridges are closed. And so we think if there is a need for physical security, it can make it more safe. We think that adding security to bridge projects will add value to the project and the community that's impacted by that bridge. And we do have solutions. And I might also add, there is money available, but it's up to the states to decide for the eligible projects that are defined in the law, can they use their state money to implement the security? Because I know that states have enough other problems with their bridges. Security usually is not the first thing of concern on their list. Usually it's how do we deal with the deterioration, how do we deal with the posting, and how do we keep the bridge open? And I have a vision, which I've been working on the last 2 years, and in my third year, is to involve more stakeholders to identify these gaps and the needs. I can come up with ideas, but I really need to hear from our state DOT partners and owners, and to, again, come up with consistent methods to manage and assess the risks, make sure we're doing it in a consistent manner, document the security measures. We talked about that. We have documents that are helping to do that using one of the 4 Ds. And again, identify how security can measurably improve the resiliency. We do have a legislative mandate to address resilience of our transportation infrastructure. So with that, I will gladly take questions. There's time.
Thanks, Vince. And we do have about 5 minutes for questions. So if you have a question, please feel free to unmute yourself or put them in the chat box and I'll read them out.
I think I'll share so I can see the chat box, for example. And I will say again, you're developing a 1-hour executive webinar. Okay, and I'm seeing some questions here.
I'll read them out. So okay. Matthew said, what are some examples of projects that have implemented bridge security in design?
Okay, so the owners don't want me to mention the bridge, but I was involved with 2 cable stayed bridges that are new bridges. And I can mention the Tappan Zee Bridge, which I was not involved with, does have bridge security measures. And these are 3 cable stayed bridges. And so there are other bridges that have retrofitted, for example, on suspension bridges, the suspender ropes. They have enclosed them in protective cylinders. And if you drive in New York, especially on the George Washington Bridge, you look at the cable suspender ropes, you'll see these collars that are around them. There are other suspension bridges around the country that have retrofitted. And I think the easiest component to retrofit are the suspender ropes or cable stays.
Okay. Sarah asked, do you anticipate any funding and requirements for local bridges to implement this plan?
Well, there is, that's a good question. And the other question is very good too. I don't have in my office a program, a highway aid program that gives out money for physical security. So that's a good question. But in the law, and there are 2 places in the law that cite that state DOTs and whoever else they give money to are allowed on eligible projects, and in the law it cites what's an eligible project, to take their highway aid money and apply that toward implementing physical security. So that gives them the ability to use that highway aid money for physical security if they decide they need to. Other than that, again, that's the only funding that's available, unless the owner itself wants to pay for physical security out of their own pockets. And in some cases, that has been done too. I hope I answered that question. Yeah, that's something. We do not have a legislative mandate that forces owners to implement physical security. So hence, that's why the legislature does allow a way for people to use that highway money if they decide to. But again, they have to balance that against their other needs for their transportation infrastructure.
Kevin McGee said, for what it's worth, US 82 Mississippi River Cable Stayed Suspension Bridge incorporated countermeasures for security and counterterrorism.
Okay, good.
I'm assuming that's the new Mississippi River Bridge in Greenville.
Yeah, I've driven by that. That's good. Yeah, I wasn't involved with that project, but I know who one of the bridge engineers was, and that's good to know. Again, it's kind of, we don't tend to advertise what we're doing to our structures. And a lot of bridge owners are very sensitive about us advertising, okay, we've done this, this, and this to protect this bridge, because it's something you really don't want to have to say. And best physical security measure is one you don't know it's there. But then again, if it's visible, it can become a deterrent.
The last question that we have time for. So first of all, James said, thank you, interesting topic. And Matthew said, being secretive makes sense. Maria asks, do you see detection measures for counterterrorism also helping with detection of other natural/accidental hazards?
Yes, for example, the fire on a bridge. If you had a camera and if the owner could see that a vehicle accident occurred and there was a fire, it might allow faster response. The other thing, relating to accidents. So the short answer is yes. And it really does depend on the type of hazard that is occurring. But yes, if you have cameras or the ability to use UASs for doing post-damage assessment, the UAS in itself could be a security countermeasure that could be used for investigating the structure or helping with inspection.
Okay, and that is all the time that we have for questions. If you guys think of any more questions for Vince, please feel free to email him. His email was on the last slide, and if you did not get that, you can let me know, and I'm happy to send that along to you. We will see you guys back here in approximately 10 minutes for the next session.
Okay, great. Thanks.